around maybe 4 to 6 months going through as a journey, lessons learned, tough things we had to do and tough decisions. So I hope it's interesting and of benefit to everyone. So I'm Mahmoud, I'm a CTO at Bexprt. Bexprt is an advanced AWS partner, and we're quite specialized. So we do mainly AI and specifically GenAI projects. We still have something we're very proud of, which is our resilience part of the business, where we go with customers throughout the journey. So we start first by getting customers to the cloud, whether it's a DR discussion or migration, and then we start landing into the innovation discussion around data and AI. We do absolutely do projects in UK and Europe, but we also have extended our work to other areas, specifically Riyadh or Saudi Arabia. So we have an office there. And we also do have a few projects across US as well, including the one we're going to be seeing today. Okay, so what I want to share today is mainly related to a solution we have, or a set of solutions under a specific suite we have, which is called BexGen. We're going to focus on a specific part of that today, which is related to IDPs, intelligent document processing. It's something that we have started with maybe 2 to 3 years back in terms of getting the best OCR technologies. GenAI was still not mainstream as we see it today. So we had many services at the time helping us to read forms, to get the right data out of there. But as GenAI came more center stage, as we started building more POCs, more agents with customers, we started founding this kind of framework around industries. So it's a framework where we have a specific set of core technologies we go to every customer with. It's all around even the enterprise features everybody is looking for, like single sign-on, a friendly user interface, being able to call the right agents and the right AI APIs, which is something that over time we were able to mature very well. But we have a story to share mainly around this intelligent document processing and how it was put along with agents to get through quite a tricky use case that we had with one of our customers. But on the way, we kind of learned a lot about LLMs, about agents specifically, and we want to share a lot about these today. So these are mainly lessons learned from the team. It's not my experience. All of it wasn't firsthand, but it's something that I was very close to and something I'm really proud that as a team we were able to achieve this. Okay, so it's a Fortune 500 enterprise. It's telco industry, and we had a very interesting use case coming through AWS. So as an AWS partners, we get always a chance to get into very exciting opportunities. In some cases, even co-delivered with professional services teams. So in this case, it was a customer that really had a lot of business critical documents, and these would not have a specific set of templates. You can group them into maybe 40, 50 document types, but even within each category, you wouldn't find a document close to another. So that's a big challenge. And that puts a lot of effort on the team that before the project were doing things manually. They have to read these documents coming through mail or sometimes email. They have to understand the landlord, the council, who's sending those documents around lease management. They have to classify them. They have to get the right info out of it and go to a database to match it. And based on that matching, they understand which team should handle this and put it into the right team. Being an automated workflow, they also need to do something more than that, or we need to do something extra, which is we need to score the confidence of being able to understand the information, get the right data, and score the matching itself with a huge database. So we have to put the right scoring that says how confident we are in terms of matching this with the right record, or in some cases, some suggested records if we have some matches that maybe we feel are very close in that case. it seemed a very interesting story, and it is actually an interesting story to tell. And we were very excited to start the project. We knew from the beginning it's quite a regulated environment. It's not an easy one to easily start putting AI within, lots of restrictions. Everything is easily putting off alarms when you put something that is not putting the right tag, the right configuration, and so on. And we wanted to ensure also that there's no unnecessary access, whether it's internet access or any public endpoint even, that we would not need. So we started this project with the goal of putting this in 3 months. We felt very lucky that we already, as an organization, we have a lot of written code. It's put as templates. It's tried already with other customers. So we were very confident about the plan that we can put it in the right time. So we have document ingestion code. We have CloudFormation and Terraform to help us in the right format. We have code to do for us extraction of data, or OCR, optical character recognition, classification, indexing. But what we really needed to write in this case, and we needed to get help from the customer as well to write very well, is an agent that would allow us to put all the right information in out of the extraction, indexing, and it would do some kind of reasoning, and that reasoning would call the right APIs, the right tools, as we call them, to be able to do the right action. So an agent, you can just think of it as a piece of software in this case that is meant to reason, to call the right APIs, and to be accessing the LLM, the large language model that we would put in this case. And I'm going to share a bit about that. So as with every project we do, let's start with a customer demo. Let's put a proof of concept for that. Let's get some sample documents and try to do like an MVP path for this. All good. And we were very happy with the results, customer happy. Let's start putting this to scale. This is where it becomes more interesting. So we want to build at scale. We're talking about thousands of documents. So the architecture itself is being revisited to ensure that everything is happening at scale. And although it wasn't the first encounter of doing projects where you have this LLM access, but usually, especially in the case of RAG and in the case of optimization, usually they have the chance to start maybe testing quality, fixing, and you're not very concerned about this scale. But when you start having automated flows and you have documents and you have lots of parallelism happening, this is where you start finding very small problems being really amplified. So in this case, we had like an average of 5 to 15%, depending on the models we were trying with, of hallucinations. The problem with these is that you have a specific workflow that has a specific output, and this output, which is scoring and routing, would really affect other systems downstream. So it's really, really important to do the things the right way. And one of the things even we started seeing when we selected an Amazon set of models called the Nova models, they have different levels like Light, Pro, and Premier. So when we started using those models, we were very happy that part of the security is already done for us. They are called content filters. If you have PII, which we already tried to filter out at the beginning, but if there's any PII, if there's any data that should not be passing through, if there's even any problems in the output coming back, the model itself, not the service, not Bedrock service, which AWS has a feature of guardrails, the model itself would filter this content and would tell us based on an error code that there has been filtration happening for a specific reason. So all these kinds of problems, including internal server errors that ideally happen when you are using very high scale or very high throughput actually access to LLMs, you start getting these problems. And this is where we started facing the first reality check. We have to see what we're going to do with this. We have a very short time frame. We really need to address those the right way. And we need to understand what we're going to do with each type of failure. So, okay, we have hallucination, that's fine. We cannot put it to zero, it's a fact. But what we can do is maybe let's try to detect first let's see if parts of the workflow, and that's why we started putting things as if we have checkpoints, we have very small tasks and actions when we go to LLMs, such that when we have a specific part of work where we have wrong output, where we have hallucination, we detect it and we do a retry. A simple retry works. So in some cases, when you do a retry, whether it's an internal server error, whether it's some kind of even unexpected filtration. So this is not PII, this is not, for example, content that should be filtered. A retry can help in this case. So that's something we would have in our code, in our loop. We have a workflow for each document, and the workflow has some areas for detection and retry. But even more interesting, and that's something we realized maybe towards the end of the project, is that the kind of acceptance that there will always be those kind of errors, and even retries can sometimes not help, has pushed us into very helpful scenario, which is let's try to handle those. Let's try to go to a specific dead letter queue. So messages are not being processed once and twice, and even on the third time, they're still not going. No more retries. We're gonna, for example, handle this by showing the customer there has been specific error and gracefully returning what we already have in terms of the content extracted, and putting this in a very, very helpful way to anyone doing human in the loop or doing manual processing to be able to handle that. So that was really an important part of understanding what can you do if you cannot fix things. And to our surprise, the customer was happy with that. No problem. If you're already handling, for example, 95% of my use case, and there are cases where some minor number of documents is going to face this, we're fine with it. Customer is happy with that as long as we are putting this in the right path. We're not losing any document processing. We're not losing any kind of processing in this case. Last but not least, in terms of accessing or sorry, handling these kind of problems is validation. You need to have some deterministic code. I'm not talking here about another LLM, because there are cases where you can put another large language model, another, for example, judge that would try to validate information, try to see what went wrong and so on, and even correct the data. We favored, as we're going to see in the next slide, what we call deterministic fixing for that. So if you can write code, if you can write scripts, this is the best way for us to be very confident that if anything goes wrong, we have already things in place that will help us to validate the data we have. Most workflows, if not all of them, would always have some part which is non-deterministic, like understanding a specific paragraph or so. But there will always be checks, whether numeric, whether they are based on specific formulas, where you really have a way to check if you're getting the right data, if you have a regex that would check the specific value of a specific key in the output and so on. So this is where we really started putting the right checks in place, and I'm going to say more about these in the next two slides. Okay, so that was the first reality check. We were handling whatever we can in terms of the workflow to gain more confidence. But this is where we start hitting another reality, which is for the same document, run it 2 times, run it 3, 4 times. There's no guarantee that the output will be the same. The output in this case should be some extraction of fields, should be some kind of scoring according to a formula. So it should be the same. You're putting the same input, you're expecting the same output, but this is not what you expect with LLMs. Things very strange would happen over the way. In some cases, it could happen on the level of even very trivial thing, like that you have some text and all you're expecting from is just a summarization. A 0 can turn into an O. Some missing character for no reason would be removed out of a literal. You can name it. There's a lot of things that could happen on that. And this is where we go to the point I was just mentioning about trying to really find the portion of processing of our workflow where we can use LLMs, which we named as non-deterministic, to create for us the right code, the right scripts that can really help us in making a bigger part of the workflow to be that deterministic. We can even let the LLM put for us all the checks that we need to get the right logic. But what we really favor to do manually or do ourselves, even if it's not manual, but through other scripts, is to verify whatever was put to us as deterministic code. So we're going to have a function, we're going to have some script to do some checks for us. We prefer to inspect it. It's generated by an LLM, but we inspect it and we accept it as part of our security and CI/CD checks before we put into the LLM to be using in this case. In our case, it was a set of Lambda functions doing some code checks and so on. So again, what we really had in this case is we want to let the LLM do the non-deterministic task, which pretty much doing in a very good way, summarizing content, understanding intentions. All this was pretty much done very well. But whenever you want some parts to be really done in a deterministic way, it's math or it's a set of logic checks like scoring that you need to do in a specific way. We started using the brilliance of LLMs in chain of thought, in putting some terms of even use case validations or some edge case validation. We started putting this more into code. This code could be generated for us by LLMs. That was the second check. We have two more to go actually on this before I show you the architecture that we had just on a high level and how we had this solution architected. The attack vectors that we face once we get into a highly regulated environment, we have to pass by some gates, we have to have some even discussions with the right teams around security, and you find them really asking about very specific parts around prompt injections, around how you deal with the output, how you ensure there's no data leakage, and so on. We even, before all this, we had a very highly regulated environment to the extent that most of the services were blocked by SCP. So SCP is a service control policy. It's a very high level switch that AWS would put on a service called organizations where you can just block the access of a service. So we had to wait maybe days, if not weeks, until we find the right team and unblock this, although we have the access to the service, but it's already blocked by an SCP. So you can just imagine how complicated this environment would be. We need to really, in a very short time frame, to go through all these checks. So some things really helped us, and I think they would apply to any project where you have Gen AI and I want to ensure there's a lot of guarantees in place if things can go wrong, specifically on the security side. So one of the things that we really found as a very good balance is that you don't have to go for the smartest model. When we talk about LLMs, we're always putting the capabilities and the least amount of hallucinations as the first metric, which is something understood and really acceptable. But in some cases, we found models, which is in this case, a set of Amazon Nova models, that they would put acceptable performance. And when I say acceptable, it means that the majority of the time they are doing really well. Maybe they're not scoring as high as another model that would maybe score like 5% better in terms of accuracy, in terms of less hallucination, but at the same time, they would require a lot of extra work in terms of cleaning the data, in terms of stopping any wrong output, or even stopping anything that could go wrong. And we're dealing here with lots of documents, sensitive documents, many things can go wrong. So we decided to go for the Amazon Nova models. It was a very good choice. We didn't have a problem in the wrong filtration. In some cases, it wasn't much, but we had it in some cases because we have, as we spoke before, the set of retries, the set of graceful handling of errors. All this was really done in a smooth way once we have those functions and those validators in place. But another very important concept we had there is we really want to ensure that we have the right guardrails. And when I say guardrails here, it's not just about a set of switches where you want some language or some maybe terms to be blocked or unblocked. No, it's really more than that. I'm stealing actually this word soft and hard from one of the reInvent sessions of this year, which is the concept of having some guardrails that could maybe in some case spark some kind of correction, or let's say in this case it's gonna remove something and put another value instead of it, or mask something. All this is what we call soft guardrail. We're still doing the processing and we still have some guardrails in place, but we're not aborting this kind of workflow. But there are guardrails which we would call in this case hard guardrails that will stop the processing. There might be an attack happening. There is a smell of some SQL injection happening in this place. So this is a kind of guardrail where you're going to stop this document processing. This is flagged or marked as something that needs to stop immediately. And that's something that we've kind of learned the hard way, learned how we do it. And we saw some framing of this from other customers who have been doing similar projects, that you really have to invest a lot in those guardrails. In addition, for sure, that AWS has a set of guardrails that you can just switch on and off, but I would always say you need levels of those. It's always a layer of security checks that you need, so you can depend on some model or bedrock related ones, and you can have your own application specific set of guardrails. The last point we have here, which was really helpful for us in terms of the discussions we have with the security teams and passing the checks, is do we really need any internet access? Even if it's access through a NAT gateway, like just outbound, do we really need it or not? In most of the cases, where we found is that the customer already has the right landing zone, has the right infrastructure. We can go to the endpoints we need for the services to do any kind of maintenance or any management or control plane layer access. It's always there through VPC endpoints. Even the load balancer, where the customer is going to access the application or the front end, no problem. It's already connected through a transit gateway from on-prem, so it's all private. So with this notion of zero internet access, we were always confident that most of the discussions would be released or relaxed a bit in terms of the attack vector and the discussion itself in terms of the checks needed for us for each and every entry point has really been lowered in terms of the barrier. So I think that's one of the things that I would recommend in any project to really check, which is, do you really need any kind of public access or public IPs or not? In our case, although we had lots of traffic back and forth between on-prem and AWS, there was really no need for that. Okay, so that's mainly it in terms of the things that we met on the way. I'm really happy to elaborate on those if we get a chance, maybe for questions after that or offline. But what I really want to end the discussion with here is just a quick run of the architecture. I'm not going to go through all the services, but I just want to highlight the impact that you would have if you had the heavy lifting done for you using serverless options. If that's an option you can do, you can see here API Gateway, S3, SQS, Lambda, all these are services that are running on a serverless fashion. AWS is doing the heavy lifting of managing the service. The scale itself and the security, a lot of this has already been offloaded to AWS and the expertise they have. We mentioned also VPC endpoints. They are pretty much everywhere where you access a database, where you access OpenSearch, which is for indexing the documents, where you start having metadata and access data. All this is happening on a serverless fashion. And maybe the last point to highlight here is that there's always access happening between the data center and between the AWS environment. So we were really thankful to the fact that we have the right networking in place, we have a transit gateway, and even more than that, we have the option of being able to go over that with the right DNS. So the DNS resolvers running on AWS and also on-prem are able to translate very well the DNS that we have on both places. Sometimes we want to call an on-prem environment to pull data. Sometimes we want to push it to the cloud. So in both cases, we needed to have this kind of architecture. That's mainly it from my side. Thank you very much for listening in.